Hello, this is Mr. Rasmussen with Algebra 2 and Lesson 118. We have more lessons in the book, but this is as far as we will go. This is our last lesson for the year. All right, and in this lesson we get back to our logarithms and actually put them in equations, and this is actually quite simple, not nearly as complex as the logarithms. However, let's review the logarithms here just a little bit. If we have the log of 100, remember if it says log without anything, that's an understood 10, right? And so really what that is saying is the log right here, the logarithm is the exponent, okay? And then the 10 is the anti-logarithm, right? The anti, if you remember, the 100 rather. So basically, this one would be equal to 2 because 10 to 2, there's the exponent, that's the logarithm, is equal to the anti-logarithm of 100. Okay, so with that reminder there a little bit, we actually use some rules for the exponents backwards, which we can do for this lesson. So for example, in lesson 113, we remind ourselves that if we had like x to the second times x to the third, right? Functionally, even though it's multiplication, functionally we add those, we get x to the fifth. Well, in this lesson here, if we have things that are if we have two logs, which are, these logs are exponents, okay, and we're adding them, functionally we're actually go backwards, actually going to multiply those, okay? And then same thing, if we have two exponents here like this, basically it'd be the same thing as a -3, which then you add, or basically you'd be subtract. Division is the same as subtraction, right? If we have subtraction like in this one, because they're exponents, we actually divide them. So let's look at example 1 here. In example 1, we notice that it's the log of 3, log of 3, log of 3. Since those are all the same, it works the same as like terms where you can work with them. So basically, if you divide everything by the log of 3, it goes away, and we can do that. So basically what we have is x plus 7 in parentheses. However, since there's a plus sign here connecting these two, same thing, because we're adding exponents, that's the same function. That's the way we actually multiply those. We're actually going to multiply these like this because we're kind of using that rule backwards. And that would be equal to 20 if I divide out my log 3. So if I multiply that out, I get 2x plus 14 is equal to 20. Subtract 14 from both sides. 2x is equal to 6. Divide by 2, divide by 2. X is equal to, looks like x is equal to 3. And it's really just that simple. With just the understanding that when we're adding logarithms, we're working backwards, and that's what we normally do here. We have to multiply them. Okay, let's look at example 2. Once again, we've got log 14. They're all the same, so that can come out as we rewrite that using our rule backwards of division. Division is normally subtraction of exponents. Since we have subtraction of the logarithms of exponents, functionally we can actually go backwards and make that division. So we actually write it this way. The x plus 3 in parentheses divided by the x minus 3 in parentheses equals 7. And so as we do that there, we're going to multiply both sides, right, by x minus 3 to cancel it here. So it looks like that. And then x plus 3 is equal to 7x minus 21. So further simplify this, add 21 to both sides, and then subtract an x from both sides. So it looks like we get 24 is equal to 6x, divide by 6, divide by 6. And it looks like our x is equal to 4. So basically, the only new part is setting up the equation correctly as you take out the logarithm part to solve it. Okay, as we move on to example point 3, get back to some of our rules there. And I want to remind, so inside of our rules for exponents, if we have x squared and then that is cubed, right? That's the same as x and x and x, which in then multiplication function you add, you get x to the 6th. Well, if we multiply 2 times 3, we get there as well, right? So this multiplication here is multiplication of the exponent, right? 3, it's 3 times 2. So if we remember, if we look at our example here, in example 3, we have log of b of x, okay, is equal to log 64. Okay, so the log is log of b for both of them, so we're eventually cancel those out. But if I put, like in the problem here, if I put a 3 in the front, it's 3 times the exponent. That's the same thing as this here. Okay, so since this multiplication is the same as writing out this way, because this is the exponent, I can rewrite this as the log of b is x cubed equal log of b 64, and then divide both sides by the log of b, so it cancels. So basically I end up with x to the 3rd equals 64, which if I cube root both ones there, that cancels out x. The cube root of 64 is 4. 4 times 4 is 16, times another 4 is 64, and that is my answer there. Okay, so same thing, we're using that idea there that this 3 multiplied by the exponent is the same as writing it out this way here. Okay, go ahead and do the 3 practice problems, and then you can check your work with my work here. All right, so practice problem A. All right, we have the log 5 of x plus 8 plus the log 5 of 4 is equal to the log 5 of 80. Okay, once again, if we divide everything by the log of 5, that all cancels out. We're left with x plus 8, and then since we're adding 2 exponents, when we add exponents, we're actually multiplying, so we want to write that as multiplication, and that's equal to 80. So we get 4x plus 32 equals 80, minus 32 minus 32. Looks like 48 divided by 4, x is going to be equal to 12. All right, and there is A. All right, let's look at practice problem B. We have the log of 7 parentheses x plus 7 minus the log of 7 parentheses x minus 2 equals the log of 7 and 10. Okay, so we can divide away the log of 7 because it's all the same in each term. We're going to write x plus 7, and then subtraction, when we subtract exponents, that's really the same thing as division. So we're actually using that backwards and writing it this way here. The subtraction of exponents is actually division, and that's going to be equal to 10. So if we multiply both sides by this, it cancels here and comes over here. We get x plus 7 is equal to 10x minus 20. Add 20 to both sides, subtract an x from both sides. Looks like we get 20. Add 20 to both sides. There we go. 27 is equal to 9x. Divide by 9, divide by 9. Looks like x is equal to 3. Okay, let's look at our last one here. Our last one is set up as 2 the log of 3x is equal to the log of 3 times 16. Okay, so this one here, since it's multiplication, that's the same thing as writing it, multiplication of an exponent. An exponent of an exponent is multiplication, so we can put that 2 here and cross it out like that. We can divide both sides by log of 3 and cancel it out there. So basically we have x squared is equal to 16, square root both sides, and we get an answer of x equals 4. Okay, and that is our answer to C. So it's really not that deep. However, just to back up here a little bit, if we wanted to look at logarithms, right, if we have the logarithm 3 of 16, basically what that's saying is we have 3, what exponent here when you multiply it by the 3 is equal to 16. So if we, oh, actually I can't do that in here because my log button's for 10. So, but anyway, that's what that's saying there. Let's estimate. How many times? 3 times, yeah, we can use this button here to experiment. 3, let's put another 3 in there, equals 27. So that's way too high. 3 squared is 9, so it has to be taller than that. So somewhere in between 2 and 3 in here, somewhere in there is our logarithm for log 3 of 16. So anyway, hope that goes well for you. Feel free to reach out if you would like some extra help on that, and have a great day.